So this is the same thing, okay? I know it's redundant, but it's in the order of what we're writing in, okay? So you can choose to not write this, it's okay, because you already have it a bunch of times, right? But all it's going here is common factoring, right? It's the same factoring by grouping. See, I'm not even looking at the solutions now. Like, this is hopefully what you guys get into the habit of too. Like, this is the order you're checking in your head. You're like, okay, well, what can I do when? Then you had trinomials, right? There's always 3 terms. Factoring by grouping, there was usually 4, right? Then you had simple trinomials. And then complex. And then today, we're going to do one more. That's still a trinomial. Okay, this will be the first part of this lesson will still be the trinomial. So you'll still have 3 terms, right? But it's what we call perfect square. These are a little bit easier in the sense if there's a little bit of a pattern to these ones, right? So if you see the pattern, you can just apply it. You don't need to show as much, like there's no MAN method. Like you see it, you recognize it, you just write down the answer basically. I'll show you how to get it, okay? The last one is what we call a difference of squares. Okay? So let's take a look at the perfect square trinomials, okay? Ever see that stuff? What's that, sorry? 2. Okay? Remember, we wrote this down yesterday. Any questions so far? We haven't done many, but okay. So, perfect square trinomials can always be solved using, you can always use like the complex method, okay? Which basically means you can use decomposition, like what we saw yesterday, or you can use the table method, okay? But the trick with these things is like recognizing what they are from the beginning, okay? And there's a little bit, they kind of stand out. They're a little bit of a special trinomial in the sense that like they look visually, if you know what you're looking for, they look differently than the rest, okay? So first you must recognize that the trinomial is in fact a perfect square trinomial, okay? And here are the rules, okay? Always has to be a trinomial. Now, before I write the next rule, can everybody look at this example here? Can you see anything that looks a little bit, not obvious, but is there a little bit of a, I don't know, do you see anything interesting about the terms that are there? Let's focus on, because they're talking about the first and third, do you notice anything special about the first and third terms in that trinomial? Yes, Retta.
The first and third terms are both perfect squares.
Which you mean by?
They can both be square rooted to something, like a whole number.
They can both be like, yeah. So they can both be square rooted. Okay? The whole term. That's important too. Okay? So if we look at that one, that's the key to these things, okay? That's why they're called perfect squares. Okay, because the first and third term are square rootable. So if you look at that, I can square root 4 and I can square root x squared. That just turns into 4x. Sorry, 2x. I can also square root 9. It's 3. You're just looking. You're like, I'm going to look at the first and third, and then go, okay, they can both be square rooted. It's a perfect square trinomial. It also works for you to say, I'm going to find two numbers that multiply to 4 times 9 and add to 12. That also works. You will see that this method that we're showing you, this perfect square trinomial method, it's faster if you can recognize it. Okay? You can see how that question doesn't necessarily look any different than the questions we did yesterday. Upon first, like at face value, you do a little bit of digging, you can see that it's a special kind of question from yesterday. You can square root the first and third. Okay? So by that, to put that into words, first and third are perfect squares. Okay, that means I can multiply two things together that are the same and create a perfect square.
I'm sorry, my desk is just so shaky.
Okay. I wasn't sure what you were doing. Okay. Now, here's the other condition though. The second term coefficient, so the number in the middle has to be even. Okay, and just as a fun fact at the end, not that I've really ever used this, I suppose it could be another method to check that it is a perfect square trinomial, but the middle expression is always equal to 2 times the square root of a times c. Okay, don't worry about that one too much. Is that okay? Okay, so you have to become familiar with these guys here. 1 squared is 1, 2 squared is 4, 3 squared is 9, 4 squared is 16. I just went ahead and wrote all those there for you, just in case you need them. If you know them, you know them. It's okay. Okay? That'll help you in identifying if you can see the 4 and the 9, they both appear in this list. Right? It's an indicator that you can do this. Right? Are we okay? So let's take a look at these, okay? We'll just do a couple questions. Did you guys get a worksheet? Did I hand a worksheet to you? Is there one stapled there or no? Is it just 2 lessons? Okay. You have to bear with me. I'll sort that out. There might be a sheet there. Okay? So, I've told you now that these are all like, we're doing a perfect square trinomial sheet. So these are perfect squares. These are all examples of perfect squares. Okay? So, here's what you're looking for. Okay? What did I say we're going to do? Square root the first, square root the last. Okay? That's your starting point. So square root of 49, we wrote in the list up here, where's 49? It's 7 squared. The square root of x squared is just x, so we get 7x. Okay? Square root of 1 is 1. Okay? The other kicker here is you get to take the sign from B and it comes here. Okay? That's just one bracket though, right? Anytime we factor something, how many factors did we get? When we were dealing with quadratics anyway. How many pairs of brackets did I always have to write? 2. So what's in the other half? Same thing. These are easy ones.
Wait, can you also just write it like 7x plus 1 squared?
Some of you came across this in the work yesterday, okay? Anytime you have 2 of the same thing, okay, you can combine them and it turns into we see that okay? I'll zoom up. Okay? This is a nice one. I like these ones. Okay, because they make your life easy. Instead of sitting there and trying to find 2 numbers that multiply to 49 and add to 14, you could do it that way. You still have to do the decomposition, which is kind of annoying, right? Like the 2 numbers that satisfy that are 7 and 7. Right? If in the event that you do this and you see, like let's say you don't recognize this as square rootable off the top, and you decide to do it man method, as soon as you find the 2 numbers that work and they just happen to match, you know it's a perfect square trinomial. Does that make sense? Okay? Because then if you do decomposition, you're going to get the same 2 pieces spat out. Okay? That's why if you can recognize it from the beginning, you save yourself the thought of trying to figure out these numbers that work, right? So that's a little bit labor intensive yesterday. See, they're writing out the factors and then coming up with the negative signs to satisfy. That's thinking. Okay? If you can avoid some of that thinking by doing this, just recognizing from the beginning, that'll save you some time and effort. Okay? Okay? Next one. Threw a little twist in here. I made the middle term negative this time instead. Okay? Steps don't necessarily change. I can still see that I square root the first and last. So it's equal to 3x and then 4. I know I'm going to have 2 of them because we just said that. What sign's going in the middle? You always square root the first, square root the last, take the sign from the middle. Those are your 3 steps. If you see a perfect square trinomial in your head, you're going to go square root first, square root last, sign from middle. Done. The other one, it was a plus sign. So I took the sign from the middle. It's plus, and I wrote it down. Okay? These are nice questions. They go pretty quick. I don't mind them. This one and the last one, okay, they're kind of nice. Okay. Square root first, square root last. Oh, sorry, we can condense this further. This says factor. I would probably say on the test, factor and simplify. Okay? The word simplify implies that looks a little simpler. Okay? What sign's going in the middle? A negative, because I see the negative there in the middle. And then you can condense it. Okay? Here's some tricky ones. I will ask you these ones because I think these are a little bit more straightforward than the complex trinomials. Okay, you could see these ones. Process doesn't change. Square root the first, square root the last. Then what? Write it out. It's 5x. Put a plus sign there. Okay. It's the square root of 121. We wrote it up in our list. Yeah, but is it just 11 or what else is on that? What's that, sorry?
11 squared.
11y.
Oh, it's y.
There's a y, yeah, I just mean the variables on there too. So it's a little bit tricky. It's just there's two variables in this one, right? But the square root of y squared is still just y. Okay, there's two of them, 5x and 11y. What sign goes on them? A minus, because it's floating right here in the middle. How do I know I'm right? Or I guess at this stage I don't necessarily know that I'm right. How would I check that I'm right? This is a better question. Yeah, Retta.
I mean, you could just do the opposite and expand it back.
Expand it. You always can expand it to check your answers. It's be like the same thing as plugging it back in, like plugging your point of intersection back in to check it. It's just an opposite process, right? So if you expand it, you should get this back if you've done it correctly, right? So and then I can condense that down further. Okay. One more. Square root first, square root last. 6x plus 4y okay? No issues? Okay, I think I have a sheet copy for you, so if not, I'll find you some textbook questions, but those aren't bad. The hardest part about those is recognizing them. And sometimes you kick yourself after doing all the work. You maybe make a mistake in your decomposition and you realize after the fact that it was a perfect square trinomial and you could have done it in 2 steps. That's annoying, trust me. There are questions and you start to you'll see, as you start to do more math with the factoring, it gets annoying when you don't pick the most efficient method and make a mistake especially. Right? Okay. Here's the next one. Okay, I just want to we're going to look for a pattern here. This one's very similar in the way that it operates, but different. Okay. So let's just, for the purposes of this afternoon, we'll practice expanding and we'll see what we get. Okay. There's a special pattern with this one. Now, just as a spoiler alert, if you look up here what we wrote with the difference of squares, how many terms did a difference of squares supposed to have? Did I tell you it was supposed to have? 2. How many terms would you normally expect to get from doing this work? 3 after you've simplified, right? Okay. Here's what's cool about these ones. What you'll notice is they're basically the same term, but the signs are opposite in the middle, right? That does something to the trinomial after you expand it, which we'll see. So that's what we're going to do here, okay? X times x x squared. I'll do this in different colors because this is good for this afternoon. You guys have to know how to do this expansion. I showed you 3 different ways of the expansion, right? Foil, the rainbow method, or the table. You could pick either of the 3. I didn't give you a lot of room here. Okay, that's kind of my bad, but particularly for the table or anything like that. But this is meant to be kind of quick, okay? X in the red is x times -6. That's going to be -6x. Okay? In the blue, I get 6x times x, positive 6x. And then the last one, we'll pick green. We go 6 times -6, -36. Can you see that okay? Yeah. Now here's what's special. What happens when you go to collect like terms here? What does? The 2 in the middle. -6 plus 6 cancels each other. So we're left with x squared minus 36. How does that relate to the questions up top? Kind of in the name, right? There's a difference. Difference being the word like subtraction of 2 square rootable terms. Difference of squares. That's how you recognize these ones. Okay? You could practice doing all 3 of these. The expansion. Okay? You're going to notice you're going to get the same thing over and over again. Well, same pattern anyway. 3x squared plus 15x minus 15x minus 25. Middle terms cancel. 3x squared minus 25. Difference of 2 squares. It's right in the name. Okay, last one. 4x squared minus 2xy plus 2xy minus y squared. Middle 2 terms cancel. 4x squared minus y squared. Okay, these save you time. Recognition saves you time. Picking the most efficient process, like what we saw with graphing lines versus using substitution elimination, saves you time. Can you imagine doing one of those questions yesterday, like one of the answers that was like -180, like as the point of intersection, and you guys trying to graph those 2 lines to solve it? You'd be there all day plotting points. You know what I'm saying? It works, yeah, sure. But it's not the best way to do things, right? Same thing here. You could use the man method for like the top questions here. Not the best method, not the best use of your time, right? Okay. So we're just looking at the fact that the signs are opposite. Okay. And both after you expand, I'll write that. Both the first, say both the terms are square rootable. Okay. Okay. These are just kind of some rules. They can fill in both of these areas. Okay. I suppose one other thing you can kind of notice is that they're always a binomial. So that there's two terms. Okay. So you can see here, just to illustrate that to you. One term, two terms. One term, two terms. Two terms. Okay? It's just a little bit of recognition, okay? And just following some rules, that's all. Everybody okay? We'll practice some questions. Are we at that stage? We're going to fill in some more blanks here. Okay, we'll fill this out too. It's been a while since I've done these lessons. I got them from somewhere, and there's some redundancies in them, so that's my apologies. Okay. But I suppose it doesn't hurt to write these things out all the time, over and over again. It kind of solidifies it. That does, like, this list at least does a little bit of a better job, like cleaning up what I just said above, okay? For you to kind of look at. Okay, that would be kind of, I suppose, those would be the rules you kind of want to abide by for difference of squares. Okay, let's try a couple. What's going to happen though? What did we notice up here? Just so I went from, remember, horizontally, okay? I went in this direction, right? From left to right, right? What we're doing this time is going the opposite direction. I'm starting over here with the x squared minus 36, and I'm trying to produce these two guys here. So what do you notice specifically about these two guys? They're the same. And what's the difference in the sign? They're opposite. That's the gist, right? So if we come down here, we're square rooting still because it's difference of squares. You can square root both of them. You're going to go 4x. This is no different than the last one, this part anyway. 4x and 5. You're going to write that twice. Okay, but here's the difference this time. One has to be negative, one has to be positive. Okay? Hopefully, if you guys know like the 3 times 3, 4 times 4, 5 times 5, you can just look at this and go, like for instance, I'll look at this one and go 3x minus 6, 3x plus 6. There's no thinking. You know what I mean? As long as you know, if you know what your perfect squares are numerically, there's no thinking. Is that okay? So the next one, square root the first. That's a little bit trickier, actually. This is okay, this is a good question. What happens? This is a little sneaky one. Okay, what happens? What happens if I square root x to the power of 4? The number's fine. We go 4, right? Still 4 and 1. What's the tricky part? The x to the power of 4. The square root of x to the power of 4 turns out to be x squared. It's a little bit of a trickier question, okay? Now, you still have two pieces here, right? 4x and 1. And difference of squares says that they have to have opposite signs, so you're going to go minus plus. But now what? This is a tricky question. Can I simplify that further? I wouldn't leave that there. Because I could again, what could I do? Square root the first, square root the last, right? I could do it again. And what's the catch this time? I'm going to get 2x and 1 multiplied against 2x and 1, opposite signs. And then what? What about this side over here? You leave it? Are you sure?
Or you could, yeah.
I'm thinking off the top of my head. We could try.
I don't know. I remember that you're supposed to leave it. I don't know though.
2x. Oh, wait a minute. Or could you square the whole thing?
Square root the whole thing? Or square it?
Square.
I'm thinking, here's what my initial thought is, whether it's right or wrong, and like this might be a stage that you guys go to, right? I haven't looked at the solution yet, right? I'm thinking, why couldn't you square root this one, square root that one?
Because it wouldn't work. Because if you do 2x plus 1, that means that it's not a difference in squares. So it'll be 2x plus 1. So it'll be 4x squared plus 2x plus 1.
Okay, so I'll write that down because it's a useful check, because I guarantee somebody's going to go through that, right, and try and do this. 2x squared, or it's 2x plus 1, 2x plus 1. Is that what everybody wants to write? Or have I pushed you in a direction to want to write that? Can we see why you might want to write that? What's the problem with it, though? If I were to expand it, I'd get 4x squared. That's fine. But then I'd get plus 2x plus 1. That is not this. It's starting to get messy, I know, sorry. Right? So I'd get 4x squared plus 4x plus 1. That's not this. So you're not allowed to do that. You can't just change it.
You just leave it, right?
You just leave it. Okay, but don't get tempted. Think, oh, I did something smart there, which is kind of smart if you can try and recognize it that way, but it's not truly true. Okay, so this is as far as you can get. Right here. Sorry, not that. Erase this. Okay. The only way to make these harder is to keep throwing more and more x variables at you, right? So for the next one, it just gets a little bit like trickier. Square root of x to the 8, that's x to the power of 4 minus 1 times x to the power of 4 plus 1. Right? You could go again, as we saw over here, with the x to the power of 4. Okay? Square root them again, you're going to get x squared minus 1, x squared plus 1. But we saw we couldn't really do anything with this anymore, right? Okay, are we done? I'll go one more because I see 2 squareds there. So then I can go, well, I see this one in particular. Okay? Anytime you see the plus sign, we saw over on the other question, we can't deal with the plus sign, so they just carry down. But if there's a minus there, that's difference of squares, right? You just keep going until you can't go anymore. So that turns into x minus 1 times x plus 1, and then you write the stuff that's carried down. Now we're done. okay? Then the last one's virtually it's identical in the sense that like it's still x to the power 4. You're gonna like square root it, but there's 100 out front. Okay, so for this one, square root the first, square root the last. 10x squared minus 5. 10x squared plus 5. I still see a difference of squares here in the first term, or first binomial. Okay, square root the first again. Can you square root 10? Okay, are we done? Okay, just checking. You're all carried away here. Is that what you got, Retta?
Yeah.
Got you. Okay, I'm not going to pretend like I intentionally did this. I accidentally did this with you guys. But it's a perfect opportunity to learn from it. Okay? Draw a line. Okay, underneath it. What did we forget to do right from the very beginning? What's number 1 always? Simplify it first by common factoring. Always. Is there anything common between those two terms? A 25. So let's factor that out first.
Wait, is that what we supposed to do, or no?
I don't know. Let's see if there's a difference between the answers. That's why I drew a line. We'll see. We'll see what we get. So you factor out the 25. I think the answer, because I can see it, looks a little bit simpler here than it does where I've drawn the line. Okay, so this is like separate. Okay, I'll do it in red actually, just so we can. Okay, so we're going to factor 25 out. What's left after you've taken it out? 4x4 minus 1. Okay, carry the 25 down. That's difference of squares. I'm going to go 2x squared minus 1. 2x squared plus 1. I still see a difference of squares there, so I can keep going. 25.
Okay.
Oh, you're right. Sorry. It's so like.
It's the same thing. It's like 10 times 10 is 100, or 25 times 2 times 2 is 100.
Oh my goodness. I'm not with it today. What did we do wrong? How come nobody says anything when I do things wrong? No, I am right. Never mind.
Factors further?
No, you're okay. Never mind. We're good. We're good. We're good. Need more self-confidence. We're good. Okay? Any questions? It's the only way to make that harder is to start throwing like more variables at you, like x to the power of 8, make you square root, square root, square root. Make you try and miss something or do something wrong, like what I'm trying to do, okay? Because it's very easy to get in the habit of just doing the same thing over and over again, and then you go too far, and then you got the wrong answer. You know what I mean? Anyway, everybody okay? No major issues?